Today we're going to look at another method for solving systems of linear equations. And we've already looked at solving them by graphing, and we've seen solving them by substitution. And today we're looking at solving systems of linear equations by elimination. So let's look at this example. What we do here is add these two equations together. And that's going to work out nicely in this case because we have negative 9y in the first equation and positive 9y in the second equation. When we add these together, we'll simply combine like terms, and when we add the negative 9y plus positive 9y, there will be no y term. Negative 9y plus positive 9y is 0y. And so then the only variable will be x, and we'll solve for x. And then, of course, we can plug that x into one of those two equations and solve it for y, because at that point the only variable will be y. And then we will have our ordered pair xy that makes both of these equations true. So first of all, you might note, well, that's just lucky that you have a negative 9y in one of them and positive 9y in the other. What if you don't have that? And we will look at those cases. But let's go ahead and do this one. So I first just want to mention that adding two equations together is a reasonable thing to do because we know you can always add the same thing to both sides of an equation. So think about our top equation. We are adding something to the left, correct? We're adding this left side of the other equation. But look what we're adding to the right. We're adding something that equals what we're adding to the left. So yeah, the bottom one is also an equation, so the negative 7x plus 9y that we're adding to the left is equal to the negative 25 we're adding to the right. We are adding the same thing to both sides in that sense. So let's do this. Let's add these together. Negative 5x plus negative 7 is negative 12x. And then, as we expected, as we talked about, negative 9y plus 9y is 0, 0y. We don't need to even write that down. And 13 plus negative 25, well, that's negative 12. Okay, so we have this. We'll just write it a little more normal. Negative 12x equals negative 12. And of course, we divide both sides by negative 12. We get x equals 1. And we now have our x coordinate of our solution. So we can take that and plug it in for x in either one of these equations and then solve for y. So let's just use the first one. So that's negative 5, and I'll just write parentheses for the x, minus 9y. We're not plugging anything in for y, of course. We're going to solve for that. Okay, equals 13. So x is 1, so we plug it in for x right there. And that gives us negative 5 minus 9y equals 13. We want to just get the negative 9y by itself, so add 5 to both sides. Okay, when we add it to the left, of course, it cancels out. When we add 5 to the right, we get 18. Divide both sides now by negative 9. And on the left, we get y. And on the right, we get 18 divided by negative 9. That's negative 2. So that's our y coordinate of our ordered pair. And so the ordered pair is 1, comma, negative 2. The x is 1, the y is negative 2. That will work in both equations if we plug it in to try it. Okay, let's look at this next one. So we said, well, you know, sometimes they're not going to just cancel like that. So this next one, we're going to have to do a little bit more work, but we're still pretty fortunate because both of these have 7x, but neither of them is negative. So if we add that together, we're not going to get 0x, we're going to get 14x. But of course, we can multiply one of these by -1 in order to get it ready to add to the other one. Multiplying both sides of something by a constant is something that is okay in algebra. It will not change the solution set at all, so you can do that. So we're going to multiply this top one by -1. So I just wrote that down, parentheses around the whole thing, and show what we're going to do. So when we do that, we'll write down here what we get. -1 times 7x, that's -7x. Okay, and the -1 times the -9y is +9y. -1 times -14 is +14. So that's what that equation becomes. And the one below, we're not going to do anything with it. We're leaving it the same. We're just going to write it down here. Okay, so now we didn't do anything that's going to change the solution sets of this system. So we're going to go ahead and add these together. So -7x plus 7x, that's 0x, just like we planned. 9y plus -10y. Okay, that leaves y. No, sorry, -y. And 14 plus -21, that is -7. So we have -y equals -7. We can solve that, right? For y, pretty easy. If you just divide both sides by -1, we will have y equals 7. Okay, so we have there our y coordinate. We need the x coordinate. Notice in the first equation, we eliminated the y and we had x as our only variable. We solved for x. This time, it turned out we eliminated x. It doesn't matter which one you eliminate. So we did get a value for y. We still need x. So we're going to plug that y in to one of these equations. Doesn't matter. We'll use this bottom one, 7x minus 10y. Okay, so that's 7x minus 10y, but we're going to plug in for y. So I'm going to write parentheses there. Okay, equals -21. Okay, all I did was write this down with the parentheses so we can plug in for y. And we're going to put in 7. Okay, so let's see what we get. 7x minus 70 equals -21. We want to solve for x, of course, so we're going to add 70 to both sides, and on the left we get 7x. On the right we have -21 plus 70. Okay, so that is in fact let's see, minus 70, add 70 to both sides. 49, right? 7x equals 49. Okay. Because if it was -20, that would be 50, so it's 49. Okay. So we solve for 7 here, or for x, I mean, divide both sides by 7. Okay, so we have x equals 7. Okay, so That gives us our ordered pair. X is 7. It's kind of too bad they turn out to be the same number, but that's the way it goes. X is 7, and Y is also 7. Okay. So we have one more example. Going to be a little bit more, whoops. As you might expect, as the examples go on, they get to be a little bit more work. So this next one, we can't just add those two equations and get something to cancel out. We also can't just make one of those negative by multiplying by -1. But if we multiply by something else, we can get it to happen, right? We can get rid of one of these variables. We can eliminate one of these. And the way we'll do that, we'll take this bottom one and we'll multiply it by 3. Okay, so what we get then, we'll rewrite both of these. The top one didn't change, so we just rewrite it down here the same as it was. The bottom one we're going to write what we get when we multiply every term by 3. Every term on both sides, of course. So we get -9x, and 3 times -9y is -27. And then 3 times 0 is 0. Okay, this looks kind of interesting, right? What's going to happen here? So 9x plus -9x is 0, of course. 0x, we could call it. Negative or positive 27 plus -27y, that is, plus -27y. Well, that's 0y. So there's nothing there so far. And on the other side, though, we have -10. So, of course, on the left, we just have 0 equals -10. Okay, well, that's not very convenient. Zero's never really equal to -10. So this is just like solving an equation. Systems of equations are the same in the sense that if you end up with a false statement, that means your solution set is the empty set. And the logic behind that is there's no value of x and y that can ever make this true. 0 is just not equal to -10. So the statement 0 equals -10 is false regardless of what x and y is. So the solution set, the set of ordered pairs that would make that thing true, is the empty set. So that is the answer. Okay, so that one just worked out that way, which is actually kind of nice. We always like those kind because we get to quit working at that point. We don't have to plug anything in to solve for the other variable. We're just done. So those are the only examples. Tomorrow we'll look at more, but for now, that's it. So see how you do on the homework, and see you later.